Good morning, everyone. Myself, Yash Kumar. Now, let's start with our topic that we have left behind using list as stacks. The list method makes it very easy to use a list as a stack where the last element added in the first element retrieved to add an item to the top of the stack. Use append to retrieve an item from the top of the stack. Use pop without an explicit index. For example, here it is an example for you to see. Now lists as Now let's talk about using list as QES. It is also possible to use a list as a QE where the first element added to the first element retrieved. If, however, lists are not efficient for the purpose, while appends and pops from the end of the list are fast, doing insert or pops from the beginning of a list is slow. To implement a queue, use collections.dq, which was designed to have fast appends and pops from both ends. Now let's talk about list comprehensions. List comprehensions provide a concise way to create list. Common applications are to make new list where each element is the result of some operations applied to each member of another sequence or iterable, or to create a sequence of those elements that satisfy a certain condition. And you have an example. Assume we want to create a list of sequence. We can make it like this. Here it is. We have written square brackets for x in range 10 squares dot append x in double into 2 square print square 0 1 2 8. We have gotten these things. Note that this creates a variable method x that will exist after the loop completes. We can calculate the list squares without any side effects using this thing, or eventually, which is more concise and readable. A list comprehension consists of brackets containing an expression followed by a for clause, then zero or more for or if clauses. The result will be a new list resulting from evaluating the expression of in the context of the for and if clauses which follow it. For example, this list combines the elements of two lists if they are not equal, and its equivalent to. Note how the order of the for and if statements is the same in both these snippets. If the expression is tuple, it must be parenthesized. You can see it here. You can read it if you want to. Now let's talk about nested list comprehensions. The initial expression in a list comprehension can be any arbitrary expression, including another list comprehension. Consider the following example of a 3 into 4 matrix implemented as a list of three lists of length 4. Here it is, you can see. As we saw in the previous section, the nested list form is evaluated in the context of the for that follows it. So this example is equivalent to this. You can see it here. It is an example of it also, which in ये भी same ही है. In the real world, you should prefer built-in functions to complex flow statements. The zip function would do a great job for this use case. Now the del statements. There is a way to remove an item from a list given its index instead of its value. The del statement this differs from a pop method which returns a value. The del statement can also be used to remove slices from a list or clear the entire list. For example, you can see here it is an example of it also. Refreshing the same name A Hereafter is an error. We will find other use of for del later. Now let's talk about tuples and sequences. Now let's talk about tuples and sequences. We saw that list and string have many common properties such as indexing and slicing operations. There are two examples of sequence data type. Since Python is an evolving language, other sequence data type may be added. There is also another standard sequence data type, the tuple. A tuple consists of a number of values separated by commas. For instance, you can see it here. As you see on output, tuple are always enclosed in parentheses so that nested tuples are interrupted correctly. They may be input with or without surrounding parentheses, although they often parenthesize are necessary anyway. It is not possible to assign to an individual item of a tuple. However, it is possible to create a tuple which contains mutable objects such as list. Though tuples may seem similar to lists, they are often used in different situations and for different purposes. Tuples are immutable and usually contains a heterogeneous sequence of elements that are accessed via unpacking or indexing. Lists are mutable and their elements are usually homogeneous and are accessed by iterating over the list. A special problem is the construction of tuple containing 0 or 1 items. The syntax has some extra quirks to accommodate these. Empty tuples are constructed by an empty pair of parentheses. A tuple which with one item is constructed by following a value with a common, but eventually, for example, here it is an example for you. The statement T 1 2 3 4 5 5 4 3 2 1 and hello is an example of tuple packing. The value 1 2 3 4 5 4 3 2 1 and hello are packed together in a tuple. The reverse operation is also possible. This is called appropriately enough sequence unpacking and works for any sequence on the right hand side. Sequence unpacking requires that there are many variables on the left side of the equal signs as there are elements in the sequence. Note that multiple assignments is really just a combination of tuple packing and sequence unpacking. Now let's talk about sets. Python also includes a data type of sets. A set is a unordered collection with no duplicate elements. Basic uses include membership testing and eliminating duplicate entries. Set objects also support mathematical operations like union, interaction, difference, and symmetric difference. Curly braces or the set functions can be used to create set. Note: to create an empty set, you have to use set not. The latter creates an empty dictionary, a data structure that we discuss in the next session. Here is a brief demonstration you can see here. Similar to list comprehension, set comprehension are also supported. Now let's talk about dictionaries. Another useful data type built in Python is the dictionary. Dictionaries are sometimes found in other languages as associative memories or associative arrays, unlike sequence, which are indexed by a range of numbers. Dictionaries are indexed by keys, which can be any immutable type. Strings and numbers can always be keys. Tuples can be used as keys if they contain only strings, numbers, or tuples. If a tuple contains any mutable object, either directly or indirectly, it cannot be used as a key. You can't use lists as keys since lists can be modified in place using index assignments, slice assignments, or methods like append or extend. It is best to think of a dictionary as a set of key value pair with the requirement that the key are unique. A pair of braces creates an empty dictionary. Placing a common separated list of key value pairs within the braces adds initial key value pairs to the dictionary. This is also the way dictionaries are written on outs. The main purpose of a dictionary are storing a value with some key and extracting the value given the key. It is also possible to delete a key value pair with delete. If you store using a key that is already in use, the old value associated with that key is forgotten. It is an error to extract a value using a non-existing key. Performing list on a dictionary return a list of all the keys used in dictionary is insertion order. To check whether a single key is in the dictionary, use the in keyword. Here is a small example using a dictionary. The dict constructor builds dictionaries directly from sequence of key value pairs. In addition, dict comprehension can be used to create dictionaries from arbitrary keys and value expressions. When the keys are simple strings, it is sometimes easier to specify pairs using keyword arguments. Now let's talk about looping techniques. When looping through dictionaries, the key and corresponding value can be retrieved at the same time using the items method. When looping through a sequence, the position index and corresponding value can be retrieved at the same time using the enumerate function. The loop over two or more sequences at the same time, the entries can be paired with the zip function. To loop over a sequence in reverse, first specify the sequence in a forward direction and then call the reversed function. To loop over a sequence in sorted order, use the sorted function which returns a new sorted list while leaving the source unaltered. It is sometimes tempting to change a list while you are looping over it, however, it is often similar and safer to create a new list instead. Now, more on conditions. The conditions used in while and if statements can contain any operators, not just comparisons. The comparison operators in and not in check whether a value occurs in a sequence. The operators is and is not compare whether two objects are really the same object. This is only this only matters for mutable objects like list. All comparison operators have the same priority, which is lower than that of all numerical operators. Comparisons can be chained. For example, A, B. You can see here. There it is given here. Tests. These tests whether all A is less than B, and moreover B is equals to C. You can check it whether A is less than B and double equals to C and it is equals to C. Comparisons may be combined using a Boolean operator and or, and the output of a comparison may be negated with not. These have lower priorities than comparison operators. Between them, not has the highest priority and or the lowest, so that A and not B or C is equivalent to A and not B or C. As always, parentheses can be used to express the desired composition. The Boolean operators A and OR are so-called short-circuit operators. Their arguments are evaluated from left to right, and evaluation stops as soon as the outcome is determined. For example, if A and C are true but B is false, A and B and C doesn't evaluate the expression C. When used as a general value and not as Boolean, the return value of a short-circuit operator is the last evaluated argument. It is possible to assign the result of a comparison or the other Boolean expression to a variable. For example, you can see here it is an example given to you. Note that in Python, unlike C, assignments cannot occur inside expression. C programmers may grumble about this, but it avoids a common class of problems encountered in C programs. Typing in an expression when n equals to was intended. Comparing sequence and other types. Sequence objects may be compared to other objects with the same sequence type. The comparison uses isographical ordering. First, the first two items are compared, and if they differ, this determines that the outcome of the comparison. If they are equal, the next two items are compared, and so on, until either sequence is exhausted. If two items to be compared are themselves sequence of the same type, the lexicographical comparison is carried out recursively. If all items of two sequences compare equal, the sequences are considered equal. If one sequence is an initial subsequence of other, the shorter sequence is called the smaller one. Lexicographical ordering for string uses the Unicode code point numbers to order individual characters. For example, of comparisons between sequences of the same type. Note that comparing objects of different type with smaller or greater is illegal provided that the objects have appropriate comparison method. For example, mixed numerical types are compared according to their numeric value. So 0 equals 0.0 etc. Otherwise, rather than providing an arbitrary ordering, the interpreter will raise a type error expectation exception. Now we will talk about modules. If you quit from the Python interpreter and enter it again, the definition you have made are lost. If you want to write a somewhat longer program, you are better off using a text editor to prepare the input for the interpreter and running it with that file as input instead. This is known as creating a script. As your program gets longer, you may want to split it into several files for easier maintenance. You may also want to use a handy function that you have written in several programs without copying its definition into each program. To support this, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called a module. Definitions from a module can be imported into other modules or into the main module. A module is a file containing Python definition and statements. The file name is the module name with the suffix .py append. Within a module, the module's name is available as the value of the global variable. For instance, use your favorite text editor to create a file called fibo.py in the current dictionary with the following contents. Now enter the Python interpreter and import this module with the following command. This doesn't enter the name of the function defined in Fibo directly in the current symbol table. It only enters the module name Fibo there. Using the module name, you can access the function. If you intended to use a function often, you can assign it to a local name. Now let's talk about more on modules. Now let's talk more about on modules. A module can contain executable statements as well as function definitions. These statements are intended to initialize the module. They are executed only the first time the module name is encountered in an import statement. Each module has its own private symbol table, which is used as the global symbol table by all functions defined in the module. Thus, the author of a module can use global variables in the module without worrying about accidental clashes with the user's global variables. On the other hand, if you know what you are doing, you can touch a module's global variables with the same notation used to refer to its functions mode name dot item name. Modules can import other modules. It is customary but not required to place all import statements at the beginning of a module. The imported module's names are placed in the importing module's global symbol table. There is a variant of the import statements that import names from a module directly into the importing module's symbol table. Here an example for you, you can see it. This doesn't introduce the module name from which the imported are taken in the local symbol table. There is even a variant to import all names that a module defines. This imports all names except those beginning with an underscore. In most cases, Python programmers don't use this facility since it introduces is an unknown set of names into an interpreter, possibly hiding some things you have already defined. Note that in general, the practice of importing X from a module or package is forwarded upon since it often causes poorly readable code. However, it is okay to use it to save typing in interactive sessions. If the module name is followed by as, then the name following as is bound directly to the imported module. This is effectively importing the module in the same way that import Fibo will do, with the only difference of it being available as Fib. It can also be used when utilizing from with similar effects. There is an important note we should look at what is it. And for efficiency reason, each module is only imported one per interpreter session. Therefore, if you change your module, you must restart the interpreter, or if it's just one module you want to test interactively, use import lib.reload. Example import lib.reload module name. This thing you can do it at the time when you want to execute it. Executing modules as scripts. When you run a Python module with the code in the module will be executed just as if you imported it, but with the name set to this. That means that by adding this code at the end of your module, you can make the file usable as a script as well as an importable module, because the code that parses the command line only runs if the module is executed as the main file. If the module is imported, the code is not run. This is often used either to provide a convenient user interface to a module or for testing purposes. The module search path. When a module named spam is imported, the interpreter first searches for a built-in module with that name. If not found, it then searches for a file named spam.py in a list of directories given by the variable sys.path. Sys.path is initialized from these locations. The dictionary containing the input script or the current dictionary when no file is specified. Python path, a list of dictionary names with the same syntax as the shell variable path. The initialization depends default. After initialization, Python programs can modify sys.path. The dictionary containing the script begins run is placed at the beginning of the search path ahead of the standard library path. This means that scripts in that dictionary will be loaded instead of modules of the same name in the library directory. This is an error unless the replacement is intended. See section standard modules for more information. Compiled Python files. To speed up loading modules, Python catches the compiled version of each module in this dictionary under the name module.version.py. See where the version encodes the format of the compiled file. It generally contains the Python version number. For example, in C In C Python releases 3.3, the compiled version of spam.py would be cached as this thing happens. This naming convention allows compiled modules from different releases and different versions of Python to coexist. Python checks the modification date of the source against the compiled version to see if it's out of date and needed to be recombined. This is a completely automatic process. Also, the compiled modules are platform independent, so the same library can be shared among systems with different architectures. Python doesn't check the cache in two circumstances. First, it always recompiles and does not store the result for the modules that's loaded directly from the command line. Second, it doesn't check the cache if there is no source module to support a non-source distribution. The compiled module must be in the source dictionary and there must not be a source module. Some tips for experts: you can use the 0 or 00 switches on the Python command to reduce the size of a compiled module. The switch removes assert statement. The switch removes both assert statements and double dash dot double dash string, since some programs may rely on having these available. You should only use this option if you know what you are doing. Optimized modules have an opt tag and are usually smaller. Future releases may change the effect of optimization. A program doesn't run any faster when it is read from a .pyc file than when it is read from a .py file. The only thing that's faster about .pyc files is the speed with which they are loaded. The module compile all can create .pyc files for all modules in a dictionary. There is more details of this process, including a flow chart of the decision in PEP 3147. Now let's talk about standard modules. Python comes with a library of standard modules described in a separate document. In Python library refers some modules are built into interpreter. These provide access to operations that are not part of the core of the language but are nevertheless built in either for efficiency or to provide access to operating system. Primitives such as system calls, the set of such modules is a configuration option which also depends on the underlying platform. For example, the WinReg module is the only provided on Windows system. One particular module deserves some attention: SYS, which is built into every Python interpreter. The variable SYS.ps1 and SYS.ps2 defines the string used as primary and secondary prompts. These two variables are only defined if the interpreter is in interactive mode. The variable sys.path is a list of strings that determines the interpreter's search path of modules. It is initialized to a default path taken from the environment variable Python path or from a built-in default if Python path is not set. You can modify it using standard list operation. The dir function, the built-in function dir, is used to find out which name a module defines. It returns a sorted list of string. Without argument, dir lists the name you have defined currently. Note that it lists all type of names, variable, module, function, etc. Dir doesn't list the names of built-in function and variables. If you want a list of those, they are defined in the standard module built-in. Here you can see it. Now let's talk about packages. Packages are a way of structuring Python's modules namespace by using dotted module names. For example, the module named A.B designates a submodule and B is a package named A. Just like the use of modules saves the author of different modules from having to worry about each other's code variables name, the use of dotted module names saves the author of multi-module packages like numpy or Pillow from having to worry about each other's module's name. Suppose you want to design a collection of modules for the uniform handling of sound files and sound data. There are many different sound file formats, so you may need to create and maintain a growing collection of modules for the conversion between the previous file formats. There are also many different operations you might want to perform on some data, on sound data. So in addition, you will be writing a never-ending stream of modules to perform these operations. Here is a possible structure for your package. When importing the package, Python searches through the dictionaries or system.path looking for the package subdirect dictionary directory. These files are required to make Python treat the directories as containing packages. This is done to prevent directories with a common name such as string from uninitially unintentionally hiding valid modules that occurs later on the module search path. In the simplest case, this can just be any empty file, but it can also execute initialization code for the package or set the described later variable described later. Users of the package can import individual modules from the package. For example, you can see this load the sub you can see it here, all these things. Now note that we in using from package import item, the item can be either a submodule or the package or some other names defined in the package like a function, class or variable. The import statement first tested whether the item is defined in the package. If not, it assumes it is a module and attempts to load it. If it fails to find it, an import error exception is raised. Contrarily, when using syntax like import item.sub.sub.sub item, each item except for the last must be a package. The last item can be a module or a package but can't be a class or function or variable defined in the previous item. Now let's see, there are some examples of it such as import sound.effects.echo, sound.effects.echo.echo filter from sound.effects import echo. Here it is also a statement of it also. Here is also from sound.effect.echo import echo filter. There is also one more echo filter input output delay 0.7 at N4. Now that our classes is over, we will talk about importing from a package in our next classes. So I hope everyone will be waiting for the next video.